Okay, we all welcome back. Now we are still on the switching. I've thought about STP. Now there are other things too I need to talk about on the switch, like um, configuration of management interface of the switch. Now, if you want to use any IP-based management software, any IP-based management software, we have so many of them online. We have Cisco View. No, normally for configuration of your network devices, like your switches and routers, we use CLI for configuration. I showed us before. CLI. When I make CLI, I mean command line interface. We don't use GUI on our network devices, but you can use GUI to configure your switch, but not on modern routers. You can use GUI to configure modern old routers, but looking at our technology now, you don't use. There's no as we don't have. Okay, the access to GUI on the router has been removed on the modern routers for Cisco routers. But you can configure switches using a GUI. But in this case, you have to install IP-based management software. As I can see on the board, we have SDM. SDM is a security device manager, and so many of them. We have SNMP, SNMP network management, and all of that. You check them online. There are so many of them online. So what you need to do is that when you install any of these softwares, you can use it to configure your switch. But before you can configure your switch, you need to prepare your switch so that you're able to have access to it using any of these softwares. Now, how do you have access to the switch? You need to put IP address on the switch. Because if you open any of this software, it's going to ask you of IP address. For instance, now if I have switch one and I have switch two in my network. Which one in particular do I want to configure? Maybe I have router. Which one in particular do I want to configure? Maybe I have a system one, system two, and system three, maybe system four here. I can stay in any of these systems and configure my switch. Now, if I install any of these IP-based management software on my system, and when I launch it, it's going to ask me of possibly IP address. So I need to put IP address so that you'll be able to locate the particular device I want to configure. So in that case, I need to prepare my switch so that I can use any of these IP-based management softwares. Now, how do I prepare my switch? Is by configuring the VLAN of my switch. You know that switch, be it 8 port, 16 port, or 24 port, or 48 ports, all the ports, they are all interconnected, forming a LAN. But in this case, it's a virtual LAN. And we call that virtual LAN VLAN 1. And it is the management, it carries the management function of that switch. Of every switch, all the switches, they have a management function which lies on the VLAN 1. And how do you configure your VLAN 1 so that you're able to have access to that switch using IP-based management software? Is it on the board? You just enter, go to global mode, of course. You configure everything on global mode. Interface VLAN 1 and IP address of the switch. That's the IP address of the switch now. Because you specify the gateway. Maybe here is my gateway of the router. I have given here gateway. So that's just that. So that if you now want to configure any of the switches, you launch it and using the IP address you've given it. So this is how to configure your VLAN 1 on the switch. Take note of that. Also, we'll continue into different ways. Switch forwards packets. So forwards frame, sorry. Packet is for routers, while frame is for switch. So different ways switch forwards frame are: one, store and forward; two, cut through switching. In store and forward, the switch will when the switch receives a frame, it goes to the FCS. Instead of the FCS, there is CRC. Of course, you remember frame. Should I say bring out frame again? Frame structure. I'm coming. Let me bring out frame structure again to remind you. Again, this is frame. This is FCS. Preamble, start frame delimiter, destination network, destination MAC address, and the rest and all of that. Inside this FCS lies CRC. That's where you can see the CRC. CRC is a cyclic redundancy check. In this, when a source is sending message in a frame, it tends to put a formula inside the CRC and use that formula to run a calculation and put the result of that calculation there. So when switch receives it, switch will use the same formula to run um, the same calculation to know whether it will get the same result. If you get the same result, yes, you now assume that yes, the the frame is validated, is reliable, or is valid, kind of. So for switch to be doing that, checking the CRC, using the formula on the CRC to recalculating whatever value, that before validating the frame, before sending it to the destination, is what we refer to as store and forward method of switching. That for store and forward, when it calculates what is inside CRC, that's store and forward. We have another method called cut through switching. Cut through switching. Cut through switching has two. It's of two methods. We have fast forward and fragment free. Fast forward is when switch receives a frame and does not check anything and just forward it, just as the name fast forward. It just forward it straight without checking anything. It's referred to as fast forward. Fragment free is when the switch is trying to check if the frame is up to 64 bits. Sorry, 64 bytes. You know that I told us before that frame in its entirety is of this range, 64 to 1518 bytes. Anything less than 64 is referred to as what? Runs. And anything greater than 1518 is referred to as giant. I told us this thing before. And anything outside of this range, switch does not forward it. Although there's exception here. There's still exception in both. When you are dealing with VLAN, if you have a switch and another switch, I have explained this thing before. Just trying to give you also a recap. I explained this thing before. If system is here, system is here, system is here, system is here, and system is here, and system is here, system is here, system is here. This one is on VLAN 2. This one VLAN. I'll talk about VLAN today, 3. This one is VLAN 2, and this one VLAN 3. If someone on VLAN 2 is sending a message to someone on VLAN 2, when it gets to this switch here, switch will tag that message with the particular VLAN number. And the size of that tag is 4 bytes. So that is only time you can have 1522 bytes. Because if you add 4 to this, it becomes 224, as in 1522. That's only time you can have frame greater than 1518. Of course, when it gets here, this switch will target. So I think it exists between the two switches. So that's that for fragment free. Fragment free is just to check if the frame is up to 64 bytes. So that is that. And again, whenever there is a collision in switch, whenever there is a collision, the garbled message or corrupt message is always less than 64. That is how switch know that, oh, a garbled message have existed and it cannot forward it because it is less than 64. So they are all runs. So that is that way. We have to, I've explained to you two types of switching, or two ways, or two methods that switch forwards message. We have store and forward. We now have cut through switching. Cut through switching is divided into two. password and fragment free. So that is that. So we get into what we have today proper. So what we have today is VLAN. VLAN. Come in. VLAN. Let me reduce my work. Please, I'm still here with you. Okay, VLAN. Come in. Switch.
Okay, sir, please, I have a question before we
Okay, yeah.
continue.
Yeah, free. You can ask your question.
Um, do we use PuTTY to configure switches or just
Yes.
for router?
Yes. Put is emulation, terminal emulation software. We have so many of them. We have PuTTY, we have hyperterminal, we have Teratem, and we have so many of them. Let me go online so that we can see terminal emulation softwares. Just type Google terminal emulation software, see a lot of them. There are many of them, but I just know that PuTTY and hyperterminal and Teratem and many of them. I don't need to go there. Just check. Just type terminal. I hope you can see my screen.
Yeah,
Terminal emulation emulation software. If you type there, you see a lot of them online. You can use any one. Of course, for you to configure your network device, you install any of them. If you when you install any of them, then it connects your system with a console cable to your network device. Then when you launch it, it will open your network device as sorry. It will open your network device. And from there you can now configure the network device. So you can use PuTTY hyperterminal
and
any
yeah,
okay. Someone was trying to say something.
your switch and IP address. Yeah,
Please can you say that again,
you said
please?
to assign an IP address to your switch.
Okay.
Yeah, you're saying to assign an IP address to your switch.
Yeah.
Just like you also assign an IP address to router.
No, the reason why we assign IP address to the switch is just for to prepare the switch so that you can have access to it using IP-based management software. But it's different from assigning IP address to the routers. What we are actually assigning IP address to on the router is the gateway. It's the gateway that you assign IP address. So router can have so many gateways. So router can have when I mean gateway, of course you understand what I mean by gateway. Like if this is my router, let me bring out gateway, please, instead of drawing everything. Give me some time. Let me bring out a gateway. So this is example of gateway. This is a router now. It has two networks, this network and this network. The gateway of this network is here. This is their gateway. The gateway to this network
Yeah,
is here. So it's
okay,
this place that you are giving IP address. You are giving IP address here. Look at the IP address, gateway IP address is this. So you can give this, and this one will have another gateway IP address according to the network.
okay.
Yeah.
Then, please, let me quickly ask my questions here.
Okay.
Uh, when you turn off the server, do you have some data erase or it has its own memory that stores data? Unlike the router, you have to save before you turn off.
Server, all devices, all computers. If you put anything there, if you configure anything or you you put anything, you have to save it. If you don't save it, you put it off, everything will wipe out. Just as if I'm on my work document, maybe for instance, I'm using a Microsoft Word and I am typing something on Microsoft Word, and maybe possibly I'm using desktop without UPS. As soon as light goes off, everything wipes out. That is if I'm using though, if I'm using Microsoft Office of anything below 2013. Because from 2013, it saves automatically, but I'm just working on assumption. For instance, okay, let's say you are using a notepad. If I'm typing something on a notepad or WordPad, if I don't save it and light goes off, if my system shuts down forcefully, everything wipes out because it stays, what I'm doing stays on the RAM, it's not on my hard disks.
Okay.
So the same thing is applicable to routers and switches. If you are doing any configuration, the configuration stays on your RAM. So when you save your configuration, it goes and stays, it goes straight away and gets stored in the NVRAM. Sorry, please.
Okay. Sorry. Yeah, more questions. If
Okay.
I so which of them with the which of the configuration with the laptop or the desktop take a DHCP settings from?
Oh, that's a very hard question. I've never, the truth is, I've never practiced that, but I believe that if you have a DHCP on your DHCP configuration on your router, and you also configure the router to be a DHCP relay, you know that normally when someone asks of IP address, you understand the dollar of a thing. When dollar occur, discover, offer, request, acknowledgement. When someone sends a dollar to your router, since router has information about IP address, there's no point of you trying to relay. So I believe that if you have DHCP service configured on your router and also still have that router as a delay agent, I believe that the DHCP service would take priority over the delay.
Okay, that's priority from server over the relay.
Yes, as on in itself, itself is a DHCP server. If you configure it as a DHCP server and also configure it as DHCP relay at the same time, I believe that itself is supposed to be the priority. So if someone asks of IP address, it has IP address. So I believe that you're going to give the person IP address. Although I've not tried that, so I need to go and confirm that in real life to know which one is priority. But why do you still need? Although, yeah, there could be situations where we can have the two. So, but you just need to maybe you can try that on packet trace and check which one is the priority. You have different network on the
Okay, thank you.
hello.
Okay.
Yeah, you can just try
Yeah,
that
okay,
on
I'm with you.
packet
Please, the
trace.
last question. Yeah,
Okay, yeah.
yeah, the last question. Yeah, you made mention of IP EPA address the last time. Please, when do you use it and what is the use of the IP EPA address? Because I did my own configuration without it and it was still working.
Yes, IP helper is when you have a server. For instance, now, if this server is the one that is supposed to give me IP address, if I need IP address as this host, I will send that I need IP address. When it hits the router will now send it to the server. Server will now reply to the router. Router will now send to you. If you want to do that, if
Okay,
you want to allow router
that
to,
means without the IP EPA address, other network cannot get it. They can't get a DHCP setting.
can you say that again, please?
I said, what you're explaining, does it mean that without the IP address, other network won't get the settings? That's the DHCP
Okay.
settings from the server.
Yes, they won't. So that IP helper
Okay,
address
okay,
actually makes your router a relay agent, a DHCP relay agent. As the word relay, just relaying
okay.
to server. So that's what actually makes it a relay agent. So if you don't have it and you have configurations on the server, as in computer, as a server. If you don't point to that server, nobody gets IP address. So
Okay.
so that's
Thank you.
that. Yeah. Please, can I have okay, looking at this place now. I hope we are all here. So looking at this place, you see that I have so many networks. Wait, I'm looking for my cursor. Hold on, I'm looking for my cursor. I hope this is not hanging. So if you're looking at this place, you discover that the okay, I've seen it. You see that um we have about how many VLANs here? I have VLAN, engineering VLAN, marketing VLAN, and accounting VLAN. Now, normally this switch has one VLAN under default called VLAN 1. So everybody on that switch, they are all connected together and they are under the same network, VLAN, virtual LAN network. But I can as well create my own virtual network in such a way that people on my anybody on my VLAN, engineering VLAN, can only communicate with themselves. Now, people on the same VLAN, if I have my own VLAN, people on the same VLAN were able to see each other. Now, if there's a broadcast here, maybe this one is too complicated. Let me do something, um, something simpler. So if I have, here is mosquito, here is something else. So if I have a switch here, I have this, this, I have this, 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 that, that. Now, if I connect everybody I connected to this place, if they are on VLAN 2, and I have so many people connected here, maybe they're on VLAN 3, people are connected here on VLAN 4, and here on VLAN 5. Only people on the same VLAN will be able to see themselves. People on VLAN 2 cannot communicate with people on VLAN 3. Do you understand? People on VLAN 4 cannot communicate outside their own VLAN. It's only systems that are here that can communicate with themselves. And if there's any broadcast, normally if there's a broadcast in the switch, everybody on the switch receives the broadcast message. But when you have, sorry, please, can I have, I'm coming, please. Okay. So, but when you have VLAN, when there's a broadcast, they won't be able to see themselves. If there's a broadcast that occur on VLAN 2, it's only people in VLAN 2 will get that broadcast. If there's a broadcast in VLAN 3, only people in VLAN 3 will get that broadcast. And VLAN 3 can only communicate with themselves. They cannot go outside their own VLAN. Now, if I have a printer in VLAN 2, if I have printer here, someone on VLAN 4 cannot print from it. Someone on VLAN 5 cannot print from it. So it's a kind of, when you are creating VLAN, you are trying to, it helps us to manage resources, reduce broadcasts, so that, because sometimes there's some department that actually, because of the way they operate, they can actually increase uh, it can actually increase broadcast activity in your network. And sometimes you could have voice, like phones and all of that in your network. You're supposed to see how you can actually separate your phones from your data network to avoid all those broadcast issues, because there's the increase, the higher or the more occurrence of your broadcast, the more tendency for you to have collision in your network. And as well, it will now result in slow network. So it's important that you understand VLAN so that you'll be able to apply it in some scenarios or situations that need it. Like as I said, printer, for you can possibly have a printer that is very costly. Not that I mean costly, like the tuner is costly. Anybody not supposed to be printing from it anyhow. For instance, you're not meant. There's some printers that you know that you can, maybe driver in a particular organization can go in and print, send print report, print every other thing and all of that. But there's some special printer you know that, oh, the tuner for those printers are costly to buy. You don't just allow everybody to print from it. So you now separate people that are supposed to be using that printer on VLANs. So that is what VLAN is. And how do we create VLAN? Or before I talk about that, I can even make a complex situation of creating a VLAN. Like now you can see that I have VLAN, people in engineering, people in marketing, people in accounting. Now on this switch, someone is on accounting. On this switch, someone is on marketing. On this switch, you have someone who is on engineering. It's only engineering can communicate with themselves. People in VLAN, in marketing can communicate with themselves. Someone here, someone here cannot communicate with someone here, in as much as the fact they are on the same switch. So important to you get to know that. So if I have all these VLAN as I have here, they cannot move outside. Uh, they cannot actually communicate outside their VLAN. So someone here can communicate down to someone here. Someone here can communicate even to a person here and all of that, but cannot go outside their own VLAN. The only reason why they can communicate with themselves is if you have a router. If I remove this router now, they cannot communicate outside their own VLAN. But if you bring in a router, they can communicate, but you can still put restriction from the router. We'll talk about that one later on. So, still on the VLAN, how do you configure your VLAN? Like for instance, too, if in real life, if I've finished configuring VLAN, maybe this one is switch one and this one is on switch two. This one is on a particular VLAN, maybe VLAN one. This one VLAN one, VLAN one, VLAN one, VLAN one, VLAN one, and all of that. These are the only ones that can actually communicate with themselves. And different other VLANs can communicate with themselves. Like these people can communicate with themselves in as much as they are on different switches. Because I created VLAN on them. Now the question is, how do we configure VLAN? We configure VLAN by, we need to open a packet tracer. This is the way we configure VLAN. You go to your global mode, you type the VLAN number and give it a name. You type the number and give it a name. Like that, like that. See the way it is. You type the VLAN, you give it a number and give it a name. You can create as many as possible before you
Sorry,
can.
number 27, where is it coming from? I know the switch port is not to 27.
No, it's not a switch port. So I can create, that we
Ah,
have a default VLAN called VLAN 1.
okay.
So I can decide to create my own VLAN from VLAN 2 upwards. Now, for instance, let's do that here. This is switch, and I have this, 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 this. So my plan is to have about uh, 4 VLANs. So let me connect them. This going to that, this going to that, this going to that. This one for my VLAN 2, for instance. Then I can start from, let's say, from 7. Port 7, port 8, port 9, according to this. Maybe I can start with from port 13 for this people. Port 14. This one is port 15. I can use port 19 for these people. 19, 20. Let's say 21. Okay. So what I did was that I'm just trying to see if I can make I'm making this group different VLANs. Let's assume I'm making this group another VLAN. Using this group another VLAN, and finally I use that as another VLAN. So these are different VLANs that I have. Now I can go to this switch and open up. Of course, you go to your enable mode, configure terminal. Now, how do I create my VLAN? VLAN 2. I have VLAN 2. Let me give it a name. Let me give it like sales. I exit. I create another VLAN called VLAN 3. I'll give it a name called production. Let me exit. Let me create another group called VLAN 4. I'll give it a name as admin. I exit and create another one as 5 and give it a name as say finance.